Well, the arrival of quantum computers could be even more historic than that.
Well, the arrival of quantum computers could be even more historic than that. We're now in the initial stages of the next revolution. It was a sad day for the scientific community when a revolutionary quantum computer had to be immediately shut down due to emergency concerns. To add to the enigma, in a shocking interview, Michio Kaku revealed some very disturbing details about quantum computing to the scientific community. He further shared mind-boggling secrets about aliens and artificial intelligence, secrets that sent shockwaves throughout the science community. Why was the revolutionary quantum computer shut down? And what mind-boggling details has renowned physicist Michio Kaku shared this time? Join us in this video as Michio Kaku breaks in tears when a quantum computer is shut down. Several mind-blowing innovations of the 21st century have revolutionized our world, transformed industries, and led us to do things that were seemingly impossible a few decades ago. From artificial intelligence to quantum computing, there's been no end to the revolutionary changes brought about by mind-blowing 21st century innovations. One area that has gained a high reputation in terms of revolutionary properties and sophistication is quantum computing. For something that started off as a mere whimsy idea in the minds of scientists, it has transformed into a groundbreaking technology with the potential to make the impossible come true. The advent of quantum theory in the early 20th century marked the beginning of the era of quantum computers. Quantum theory, a ground-shattering theory of physics, explains how atomic and subatomic particles behave and also serves as the basis for quantum mechanics, which ultimately laid the groundwork for quantum computing. However, the idea of quantum computing did not gather momentum until 1980 when scientist Paul Benioff suggested employing quantum systems for computation. He boldly proposed that a new generation of sophisticated computers may be built using quantum mechanics to take advantage of quantum phenomena like superposition and entanglement. The phenomenal theory was finally developed by physicist Richard Feynman in 1982. Feynman envisioned a new breed of computer systems that would be built off the principles of quantum mechanics. His argument was that this new breed of computers would be able to tackle problems that are impossible for conventional computers to handle. The idea was a revolutionary one, but initially it was just a mere theory. Quantum computing didn't materialize into anything substantial until the 1990s, when some genius minds began to take giant steps to see Feynman's dream come true. From the great mathematician Peter Shor to the great Albert Einstein himself, several geniuses contributed to the quantum dream. Back in 1994, Shor developed a quantum algorithm so profound that it sent shockwaves throughout the scientific community. Thanks to this mind-shattering algorithm, experts could finally see the potential of quantum computers in breaking encryption systems and doing other impossible feats. This spurred a new interest in the pursuit of inventing quantum computers. It wasn't until a decade later that the first practical, hands-on quantum computers were born. The first quantum computers were nothing to write home about, barely able to produce a solution from inputted data. A prime example of this breed of quantum computers was Isaac Chang's 2-qubit quantum computer created in 1998. Isaac Chang, a researcher from the Los Alamos National Laboratory, had help from Neil Gershenfeld of the Massachusetts Institute of Technology and Mark Cook of the University of California. Together, the trio made what we can agree to be the first quantum computer, aptly demonstrating the principles of quantum computation. However, in view of the larger picture, the invention was quite trivial because it couldn't solve meaningful problems troubling the scientific community at the time. The most downcasting aspect of this quantum computer was that it featured only 2 qubits. A qubit is a paraphrase for a quantum bit. It's the basic entity quantum computers use to store and process information. The more qubits a quantum computer has, the more powerful it is. Isaac Chang's 2-qubit quantum computer would be completely useless compared to a 10,000-qubit mega-quantum computer. However, the beauty of quantum computing is not just in the quantum mechanics or the number of qubits they employ. These qubits themselves have extraordinary properties, totally different from what you find in non-quantum computers that use bits or ones and zeros. You see, qubits have an exceptional ability, superposition. Take, for example, a bit in a normal computer. It has to be either 1 or 0. A qubit, on the other hand, can represent both 0 and 1 at the same time. It's like these tiny data entities can read the situation and superimpose themselves as the situation demands. This single property is what has opened the minds of several scientists and quantum physicists to the mind-boggling potential of quantum computing. Experts realized that quantum computers can solve problems much faster than classical computers on an unfathomably large scale. Another interesting feature of quantum computers is the quantum gates. These gates serve the function of manipulating the quantum states of qubits in order to carry out specific computations or run algorithms to reach a targeted goal. It's all a sensational mode of operation, so sophisticated that it would leave you speechless. 2001 was a remarkable year for quantum computing enthusiasts. It was the year a group of scientists from IBM managed to use nuclear magnetic resonance to control qubits. It was truly the first perfect execution of Shor's algorithm, and it both baffled and inspired scientists to pursue more quantum breakthroughs. It wasn't long after this that scientists began to make more sophisticated quantum computers. The number of qubits in these computers kept growing, allowing for more complex calculations to be made. In 2010, another groundbreaking achievement, quantum teleportation, was achieved by researchers at the University of Science and Technology of China. This enigmatic phenomenon entails the seamless transportation of a particle's quantum state from one point to another. Scientists involved in this research project were successful in teleporting quantum state particles over impressive distances of up to 10 meters. This was a noteworthy accomplishment, proving that quantum information could be sent across vast distances, essential for creating quantum networks. In 2013, the greatest quantum project of all time was initiated when Google and NASA combined forces to create the revolutionary D-Wave computer. The powerhouse was located at NASA's Ames Research Center. From hunting for new alien worlds to enhancing Google search engines, the potential of this technology was limitless. Har-M Nevin, who was director of engineering at Google during the launch of this groundbreaking technology, had this to say about D-Wave 2. We believe quantum computing may help solve some of the most challenging computer science problems, particularly in machine learning. Machine learning is all about building better models of the world to make more accurate predictions. If we want to cure diseases, we need better models of how they develop. If we want to create effective environmental policies, we need better models of what's happening to our climate. And if we want to build a more useful search engine, we need to better understand spoken questions and what's on the web so you get the best answer. D-Wave 2 practically made the impossible become possible, solving optimization problems 10,000 times faster than classical computers and tackling several machine learning problems. There was no doubt in anyone's mind that the skies were the limit for this revolutionary tech. Some experts at NASA were even suspecting it would prove alien existence once and for all. You see, shortly after quantum computing began to take root, a certain theory began to rise among astronomers and cosmologists. It was the idea that quantum computers and black holes share a deeper connection than we ever thought. According to quantum mechanical principles, black holes are the most efficient stores of quantum information. In fact, many theories have risen within the scientific community suggesting that extraterrestrials may be using black holes as quantum computers. According to these theories, this all explains why black holes are so mysterious and why extraterrestrials have been so elusive. Some astronomers predict that if we could somehow make computers that are based on black holes, then finding extraterrestrials would be as easy as pie. The D-Wave would have been a good step in the right direction to make this dream come true. However, much to the dismay of everyone working on the project, the government shut down the D-Wave supercomputer project soon after. The shutdown became necessary due to a major fear within the scientific community, the fear of the computer being used for hacking and other unconventional purposes. Understandably, quantum computers are so sophisticated that they could be used to hack encryption systems or decode cryptographic algorithms. Cryptographic algorithms are the backbone of any encryption system. These enigmatic equations play the role of scrambling plaintext, primarily for data encryption and authentication to enable secure communication or privatization of data. Before now, nothing could crack these encryptions. However, quantum computers have become the game changers in this regard. For instance, if you fail to have the code to $1 million safe, you could use a quantum computer to decode the codes and open the safe. So you can see why the government and the general public were worried. What if the technology was manipulated? Or what if the technology got into the wrong hands? While NASA may have had to pause in its search for alien worlds with the D-Wave 2, Google pressed harder. So much so that the company achieved quantum supremacy in 2019. The massive breakthrough was possible thanks to Google's superhuman quantum processor, known as Sycamore. Quantum supremacy is the phenomenal demonstration of how a quantum computer can solve a problem impossible for any classical computer, and in ample time too. The crazy fast processor in Google's quantum computer was able to solve a million-year classical computer problem in mere seconds. It was completely astonishing, opening the eyes of scientists and members of the public to the incredible wonders of quantum computing. By 2020, IBM made a comeback with the IBM Q system, the very first fully integrated quantum computer designed for commercial use. This was a dream come true, as all other prior quantum computer models were exclusively for research or non-commercial uses. For the first time ever, members of the public had a chance to lay their hands on a customized quantum computer and use it as necessary. However, this discovery also meant that a brand new age had begun for quantum computers. And finally, agencies like NASA could resume their pursuit of extraterrestrial life forms. The existence of extraterrestrial life forms is highly probable, and with quantum computers, we may finally be able to solve the Fermi paradox. The Fermi paradox is the scientific term given to the contradiction between the likely existence of aliens and the lack of proof of such alien existence. If truly advanced civilizations have entered our galaxy, there should be substantial proof of their activities throughout our galaxy and planet. Right? Well, what if we've never found advanced civilizations because we've never used the right technology? What if these extraterrestrials use technology so sophisticated that only next-generation tech, like mega quantum computers, can shine light on their existence? This is the argument and controversy among astronomers and cosmologists, and several renowned experts, like Michio Kaku, have begun to give their take on the issue. These experts are suggesting more advanced means of search, such as energy neutrinos and quantum communications. Michio Kaku, in an interview, suggested something completely extraordinary in a mind-blowing notion. Michio Kaku suggested the existence of some sort of secret alien superhighway through which billions of aliens could be navigating our cosmos unnoticed. This mind-shattering theory may just be the solution to the mystery of aliens and extraterrestrials, but until our technological capabilities can verify this, we may never know for a long time. Scientists have based their research on extraterrestrials primarily on searching for radio signals from distant star systems. However, this limited search strategy may be reducing our chances of discovering evidence of alien life. Maybe someday, when we can unleash the true power of quantum computers, we may finally be able to explore our world to find this elusive superhighway Michio Kaku referred to. No one truly knows the full extent of quantum computing. For now, it's been proven to be capable of highly sophisticated tasks like large-scale optimization, complex simulations, and supersonic machine learning. But until physicists have learned to fully manipulate and control the qubits that make up these computers, we may never see quantum computing shine in its full glory. The only remarkable feature noticed so far in the world of quantum computing is the quantum entanglement of qubits. When this happens, it's like qubits are doomed to suffer the same fate regardless of how far apart they are. In other words, the quantum state of each particle cannot be independently analyzed, and they affect each other even if they are light years apart. Albert Einstein once referred to this action as spooky action at a distance. Thanks to this phenomenon, qubits can work together to perform vast amounts of tasks and processes simultaneously. It's one thing that makes quantum computers so fast in solving problems or unlocking encryption sequences in a flash. Some experts have predicted that in a 5-year time frame, quantum computing will transform encryption as we know it. Now you may be wondering, is that a good thing? Shouldn't we be worried about quantum computers being used for hacking and other kinds of threats?